Okay, so let's get started. We're going to be taking a look at working with our cranking, post-start, and warm-up enrichment fuel tuning found within our Motec M1 systems. And we need to make sure that this is correct so the engine can crank, fire, and run at an appropriate lambda as the engine is coming up to operating temperature or coming out of a cranking type of condition. So we have a lot of different variables to account for here. We're going to talk about what tables are associated to these tuning tasks, how to deal with these tables, and then going through and understanding just the broad concept of how these tables are actually applied in our fueling routine. Very important to understand the basics and fundamentals so we know how to apply proper changes to those specific tables. Let's jump in here and take a look at where we can find all of these tables within our tuning layout. This is going to be the main M1 course layout we find in our training course folder. We're going to be working in the tuning section here, and then we're going to jump over to our second page under our startup fuel. This is where we find all of the tables and parameters that are going to be associated for editing to get our engine to crank, fire up, and run, and again, run at appropriate lambda amount as the engine is coming up to operating temperature, as it exits our cranking conditions. Now, if you have a different firmware package, I am working with a GPRP package. So the GPR and the GPRP packages are virtually the same. What we have in here is essentially what we're going to be able to calibrate and tune. If you have a different firmware package, they may include slightly different tables. Specifically, they might add in a prime pulse table. We'll talk about that functionality here in this training module as well, but we don't have that present to actually calibrate and tune with this firmware package. Again, I'm working with the GPRP package. So let's jump in here and talk about what tables we have to deal with here, and then we'll talk about the big picture, what's going on here, and then we'll deal with what we need to actually put into these tables to get the desired results. So we find that we have a cranking fuel table, and they're going to be calling this in Motec terms engine crank fuel volume compensation percent. And we can see that we also have a cranking airflow table, we have a cranking spark timing table, we have a post-start fueling table, we have a warm-up enrichment table, and then finally we have our target lambda table, and then we have our lambda offset, and they're going to be calling this coolant temp fuel mixture aim. We also have in our startup tuning parameters here, we have a flooded throttle position that's going to act as a clear flood type of function, shutting off the injectors, allowing us to clear out the combustion chambers if we think the engine is flooding from, let's say, too much cranking fuel here. So we have a whole bunch of different things to kind of put together in order to get the desired result, in order again to have our engine crank, fire, and run properly. So how does this all fit together? Well, first things first, I have coming up on screen a nice schematic that's going to explain the functionality and the flow between all of the tables and how they're all going to be interconnected. So looking here at our schematic, we're going to find our one axis is based on injector pulse width, essentially the fueling that we're going to be delivering into our engine under various different conditions. The bottom axis is going to be our time. So all the way to the left would be 0 time. We haven't cranked our engine over yet. And then all the way to the right would be as the engine is cranked over, fired, ran, and it came up to operating temperature. That would be essentially the end point of that axis. So what we find within this table is going to be a bunch of different terms, and we're going to relate those back in here to the tables that we have on screen. So we first find we have a prime pulse that's going to be in our orange color. Now the prime pulse is absent from this firmware package, but traditionally it's used with a fuel injection system. It's going to add a big shot of fuel into the combustion chamber or into the back of a closed valve. It's going to just essentially prime all of the injectors the same. The goal is to get some fuel into the combustion chamber to pre-prime so that we can get some combustion started to help us get the engine to crank and fire up a little bit quicker. Again, this firmware package does not have a prime pulse table. If you're using a different firmware package, it may be available. So the prime pulse is something that we don't have to worry about in this particular case, although it is useful for getting the engine to fire up and run a little bit quicker. The next thing we find is our cranking fuel here, and that's going to be found in the purple. What we'll notice about our cranking fuel is that in this case, we have a dotted red line down below, and that's going to be the base pulse width coming from our volumetric efficiency table. So looking at this, when we're here in a cranking condition, we're essentially going to be at atmospheric pressure. Notice in our VE table here, engine efficiency table, that we're located here. So we have our engine speed is 0, the inlet manifold pressure showing 100. I'm about sea level right now, so I'm showing in this case that I'm operating at this particular cell point. I'm estimating my volumetric efficiency at 60%. That's going to allow the Motec to calculate what the engine load or air mass is going to be right now. So 354 milligrams.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.